Okay, here is the answer. The 4 factors are the first one, as I said, the temperature. Second one, of course, is one of the variable, which is pH. The third one and the fourth one is a bit harder to think about, but if you could pay attention to the video I mentioned previously, you will know they are the concentrations of substrate and enzyme separately. Alright, I'll talk about each factor one by one. So firstly, which is about the temperature, the graph should look like this. Alright, so you will see when the temperature is low or when the temperature is high, the rates of reaction will be slower. That means the time that it takes will be way longer. Alright, so the diagram will look like this, which means that there is a point which is what we call the optimum temperature here. Alright, I really want you to remember this word. Alright, that is the specific term that we use for the best temperature. By saying best temperature, it means that you can get the highest rates of reaction. So it means it worked the best at this condition then. Alright, and another thing is you got to pay attention that the graph is not symmetrical. That means the left side and the right side are different. Right, because you can see this side is a bit on the right side is a bit steeper, alright, while the left side is less steep. We will talk about that later on. So when you are asked to describe, alright, since this is a description, if you look at the title here, if you are asked to describe what happened in the graph here, then the first parts that you need to talk about is when the temperature is higher, then the enzyme activity would also be higher until it reached the optimum temperature. Alright, which just now is around not yet 40, but how many is it? How much is it? It will be around 37 degrees here. Alright, and let's think about why 37 degrees. Why is it so special? And the second sentence that you want to raise about, of course, the turning point, the optimum temperature, which is just now the peak in the picture here. Alright, so if you are going to write this, then you are going to say, oh, this is the point where you can have the best or the highest enzyme activity. The last one, of course, you can see that in the graph is going slower and slower at last, which means that when you try to describe it, you have to say when the temperature go higher than the optimum temperature, then the activity would decrease. Alright, or you may say the rate of reaction is slower. So that's the description of the graph itself, but this is not the explanation, right? For the explanation, you will see, wow, there's a lot of words here. So let's go through it one by one. For the first one, if you recall the graph, it basically goes up, alright, and it goes down. So that is, this part is the first part. So this is the first part, number 1, and this is part 2, and lastly this part is number 3. Alright, when you try to write down this word, maybe you can try to think about to draw the graph together with the explanation and description together, so that it may be easier for you. Anyway, for stage 1, since the temperature increase here, it moves faster with higher kinetic energy as temperature increase. So they are more likely having more possibility, or you may say higher probability to collide. Collide means they will hit together and form the enzyme substrate. If you recall in the simulation, that is how they do, right? They have to randomly meet each other so that the enzyme can help the substrate to do the reactions. And second stage, which is at the optimum temperature, well, actually there's not much explanation here. There's actually just a point that which is the best for that kind of enzyme. Right? This is quite kind of natural. However, if the temperature is too high for the enzyme to sustain, what will happen to the enzyme is it will lose its shape, and we call that with a specific fancy term called denature. Alright, and by saying that, it means the shape of the enzyme will change. So if you don't still understand about denature, you can have a look of this. Normally, this is the enzyme and that is the substrate. Alright, so what they do is they help you to fit in together and try to do the reactions, right? But if there is any heat given to the enzyme which beyond the limit, which means the optimum temperature, what will happen to the enzyme is like this. You see the shape got change and transform. Alright, so do you think the blue substrate can still fit into the enzyme? Of course it won't fit anymore. So basically this is a definition of denature, which is the shape is lost when there is heat, too much heat applied. And or you may look at this picture to show that the same idea, right? With the active site change the shape so that it can fit with the substrate. However, if we think about the lock and key theory backward, if you still remember that enzyme is treated as the key, right? So what does it mean if the enzyme is denature here? So what would it look like for the key then? Can you try to use some imagination to think about that? Right. Then the enzyme, I mean the key, would look like that. So that's why I'm sure you know the key would no longer help you to open up the door. Okay, so how about pH value then? How would the pH value affect the enzyme? If you could recall the simulation that you have done, then you may find out when the pH value is too high, the enzyme actually literally cannot turn any substrate into the product. So that's why they would not work. But it's not really true that all the enzymes look like this. Let's have a look at this. There is two kinds of enzyme. One is called pepsin and the kind is called trypsin. So for different enzymes, they have different optimum pH value because they are, let's say, they are in different parts of your body. And of course, if you try to search their name, you will know that pepsin is at your stomach, and while trypsin is from your pancreas. Alright, although they are both protease, but they have different optimum pH value. Can you have a look of the optimum pepsin pH value here? Of course, you look at the peak of this and the peak of trypsin. You try to draw a line downward. Oh, that is not a really good line though. Alright, let me draw again. A straight line. Alright, if you can do it with ruler, you can do better than me. So for pepsin here, the optimum pH value probably you would say 2, 3. Alright, so between 2 and 3, maybe this one is 2.5 basically. While for trypsin is about 8, 9, 10, so between 9 and 10, so maybe 9.5 or 9 point something, right? So that's the optimum. Alright, optimum means the best, right? Optimum temperature? No, of course this is not temperature. This is the pH value, right? So the optimum pH value. So for the graph description, it's a bit similar to the denature part in the temperature section. So the first thing you want to say is, of course, again, the optimum pH value will give the highest enzyme activity. Alright, remember this is a description, that is not the explanation. And then the further away from the optimum pH value, the lower activity would be. And the reason, alright, so this is the reason. This is the reason, which is the explanation. So if the question asks you to explain, you're going to say this out. They will lose its shape because, again, they will denature because of the extreme pH value, like too acidic or too alkaline. Of course, it really depends on which kind of enzyme it is. So therefore, usually when we talk about a general kind of enzyme, we would sometimes draw the graph like that, right? With too alkaline or too acidic pH value, they will both denature. Alright, while for the temperature one, you would say for stage 1, which means the first stage here, we would not call that denature. So if you say it is denature, it is not correct. Alright, it's only correct when you say it's too hot, when we talk about denature here. Alright, it's okay for stage 3, but for stage 1 you can't say denature. By the way, you would never say the temperature or the pH value kill the enzyme. Alright, you never say they are killed, because enzyme itself, they do not have any life, so you can't say kill. Alright, you got to say denature for high temperature or too extreme pH value. So how about this then? How would you say the low activity here? We will call that with one word, with I, which is called inactive. Alright, so this is also a word that you need to use when you are trying to describe the activity in the low temperature. So how about the concentration then? We have finished talking about the temperature and also the pH value. So let's move on to the concentration of substrate and the enzyme. So you can take reference of this picture. Let's say from panel 1, 2, 3, you can see the difference. For 2 and 3, they have higher amounts, more amounts of substrate here, which means the substrate concentration is higher within the same space. Alright, if you're putting them into 3 different containers, they have the same space. So for concentration wise, for this one we have high concentration of substrates. So how would they be different when you're talking about the rates then? If you try to draw the graph, they will look like this. No matter it is substrate or enzyme concentration, they will both look like this, right? Similarly. So this time I'm not giving you the description and also the explanation in this PowerPoint. I want you to try to write it down on your notebook and tell me during your lessons. And basically you need to just do it on one graph will be fine, right? And you got to separate them into 2 stages. So one is the part that are going like this, and the second part is going like this. Alright, remember you need to talk about 2 things. One is the description and the second one is the explanation. Alright, how do you explain them? So let's talk about it during the lessons later on.